So let's talk about weathering. And weathering is when you start with a rock and then it's broken down in place. It's not going anywhere. It's not rolling down a hill or being pushed around by a river. It's just breaking up in place. And if this happens by some physical process, we call that physical weathering. So let's look at some examples of physical weathering. One way to get physical weathering started is to have cracks in the rocks. And these cracks can be the result of regional stresses, maybe regional tectonic stresses, but these cracks tend to form parallel to each other. We can kind of see there's three different orientations of cracks here. One's running like this, others running like this, and then one's running straight across like that. Not all perfectly aligned, but three directions where the stresses are causing these cracks to occur in the rock. We can also see those cracks are not very deep, maybe an inch or even less deep in this area here, but over time these can grow into cracks that extend through tens of feet of rock. Let's look at this from the side now. So here's some rock climbers. Rock climbers love these cracks in the rocks. These cracks in the rocks are called joints, and the joints have no movement associated with them, so they're not faults. They're just cracks in the rocks that are the result of these regional stresses. And once again, we can see that the cracks are lining up here. These are all parallel to each other, and there might be another one that formed this face of the rock all through this area here. Associated with these joints, we also have these horizontal layers, which are actually from the bedding of this sandstone through here. So we have a big gap in the rocks here, big gap in the rocks here. And of course, with all these gaps, both from the joints and from the bedding planes of the sandstone, that's what we call the boundaries between these different layers, the bedding planes, we can get a lot of empty space where different things can happen. One thing that can happen is water can get in there and then it can freeze. And if water gets into joints and then freezes, it can cause this to occur. If you ever made a tray of ice cubes and filled it to the top, you might have noticed afterwards the ice actually goes higher than the top of the ice cube tray because ice expands when it freezes. That's why ice floats on top of the water when a lake freezes. When it goes into rocks and then freezes, the ice also expands and it actually pushes the rocks apart, or it even can push the rocks upward if it gets into a horizontal crack such as this. So this is one way that physical weathering can occur, and we call this type of physical weathering frost wedging. So by this freeze and thaw cycle, first the water gets into the rocks, it freezes, it pushes the rocks apart. If at a later date, if all that ice thaws and then it freezes again, the same sort of thing is going to happen all over again. So this frost wedging can cause these rocks to actually weather in place by a physical weathering process. If you've ever driven down a road that's been very wedgy in the wintertime like this, that could be frost wedging. That could mean that water is getting underneath the road, and as it freezes, it's pushing up the road in certain areas and kind of giving it this washboardy sort of feel as you drive across it. And frost wedging doesn't have to happen in an outcrop. You could just have a rock that's sitting on top of soil here, and if there's a crack in it, this can happen over time, and it can actually pry an entire rock like this into two different pieces. So two more examples of frost wedging here. Another way that rocks can physically weather is by changes in pressure. So remember when we talked about plutons, we could have a deep igneous intrusive rock that we would call a pluton. And as that rock is forming, as it's going from a liquid magma to a pluton, it has all the weight of the rocks on top of it to contend with. It's actually being compressed because of all of the weight, or being put under pressure because of the weight of all of the rocks on top of it. However, when it comes to the surface, like Half Dome here, we can see that suddenly all that pressure on top has been relieved, and this can cause the top layers of the rock to flake off. And we can see this flaking occurring over here at Half Dome. There's some people hiking up to Half Dome there. We can see all of these thin layers, like layers of an onion, that are kind of slowly peeling off because Half Dome is under a lot less pressure than it was when it formed. And so this process is called exfoliation, F-O-L-I-A-T-I-O-N. And that means just the outer layer of rock is peeling off because it's under a lot less pressure than when this igneous pluton formed. And another type of physical weathering that can happen is this root wedging. So in this case here, there's a crack in the rocks like a joint, a little bit of soil gets or dust gets blown into that, and then a seed gets blown into that and plants start to grow. This is a mild case here where we have some kind of plant growing in a crack in the rocks. But over time, as roots get bigger and deeper, these things can completely break up rocks, and through this root wedging can really weather away the rocks in an area in a physical manner.